Okay, so lipid metabolism. Lipids can be used for energy. Lipids can be used for energy storage. Okay, so we get fats through our diet. Okay, and then we have our stored fats as well. So we're basically talking about triglycerides here. Okay. So triglycerides. Triglycerides are basically a glycerol and three fatty acids hanging off of it. So a triglyceride can be broken down into the glycerol, and its fatty acids. Okay. All right. So if we look at the triglyceride, let's see how do you want to put this. All right. So going this way, so we have our triglyceride. If we break down into glycerol and fatty acids, that is lipolysis, right? So there's a breaking down of fats, okay? Triglycerides can also be made in the body. So these reactions can be reversed. So that would be lipogenesis. Okay? All right, so what can we do with the glycerol? Well, the glycerol we can convert into a molecule that can enter either glycolysis to make energy, or it can be converted through gluconeogenesis to make glucose. So that's one thing that it can do. So if we break down glycerol, we can convert it to a molecule of glyceraldehyde 3-phosphate. So that is the molecule. If you remember, it was an intermediary in glycolysis. So in glycolysis, remember the glyceraldehyde phosphate, that's what got clipped into the 2,3 carbon molecules that ended up as pyruvate. So we end up making pyruvate. All right. Or we can even go the opposite direction, take pyruvate to make glyceraldehyde phosphate, and we can either make glucose, or we can go back here and make glycerol and then make triglycerides. Okay, so this intermediary that comes from glycerol can do a couple of things. Okay, so it can enter glycolysis, make pyruvate. It can go through gluconeogenesis and make glucose. Okay, if it makes pyruvate, so what happens with that? Well, if it makes pyruvate, then it's going to either go, if we have pyruvate and no oxygen, it will go make lactate and go into fermentation, or if it has oxygen, it'll enter the mitochondria and convert to acetyl-CoA. If it does that, it can go into the citric acid cycle and electron transport chain, and we get lots of ATP. Okay. If it cannot enter the citric acid cycle, then it will take a different route and make ketone bodies. All right, and ketone bodies can also go in the other direction and make acetyl-CoA. Okay, acetyl-CoA can also be used to make fatty acids. Okay, fatty acids, when we look at how fatty acids are processed, fatty acids go through something called beta oxidation, and they make acetyl-CoAs. And then those acetyl-CoAs then go into either the citric acid cycle, electron transport chain, make lots of ATP, or are converted to ketone bodies. Ketones are another way to make energy, or the muscle can use ketones for energy, and in fact it's preferable for muscles to use that, more efficient. But again, they can also be reconverted back into acetyl-CoA. All right, so I'm trying to think of what else I need to let you know here. Okay, so that's basically what happens with fats. So I'm going to talk about what beta oxidation is and how fatty acids create ATP, and then we'll talk about fatty acid synthesis.